Hi, I'm an old guy and I do maths. If you've read the header for this problem, it's fairly complicated. So what I've tried to do here is to try and break it down into manageable pieces. And I'm not going to do my working on this page. I'm just going to refer back to this page as we progress through the problem, because in order to get to our answer, there's a fair bit of work to be done. Okay, two lines occupy a Cartesian plane. The first line has an equation y equals x plus 1, and I've done a rough sketch here. This is y equals x plus 1. It passes through the y-axis at 1. It has a gradient of 1, and therefore it hits the x-axis at -1. That's our first piece of information. We know that there's another line somewhere. The second line, number 2, intersects 1 at the point 2, 3. So let's say that that's 1, that's 2, that's 3, and we want 0, 1, 2, 2, 3. We will call that 2, 3. And there is some sort of point of intersection there at the point 2, 3. This is not drawn to scale. This is just me roughing out this thing so that I can get an idea of what I'm looking at and what I'm dealing with in terms of the problem. So this point here, 2, 3. So we'll put a 1, 2 and a 3 there, 1 and 2 there, 2 across, 3 up. That's there. Okay. Next point. It intercepts the x-axis at x equals 6. So the second line, and it is a line, hits the x-axis somewhere over here at 6. 3, 4, 5, 6. So what we've got is we've got something like this. Okay. And the question is, what angle does line 2 make with the x-axis? So, I'm going to assume we're looking at this angle. We might investigate this angle. I think that the sensible idea is to investigate this angle. Why? Well, there are a couple of ways into this. One way is to figure out the gradient of this line. If we can do that, the gradient of a line is equal to the tangent of the angle that it makes with the x-axis. Just let me draw in a triangle here and you'll see what I'm talking about. Now, gradient is rise over run. We have a rise of 3 and a run, 1, 2, 3, 4, of 4. Now, that's in the negative direction, so this is -3 over 4, but let's not split hairs at the moment. We've got a triangle that is 3, 4, and presumably because this is a right angle, that's 5. We don't need that, but that's just a bit of information for you. Now, as I said, we could work out the gradient of this, which I have just done, as it turns out, and our gradient is -3 over 4. Why am I so confident that it's negative? That is a line with a negative gradient. That is a line with a positive gradient. Bottom right, top left, negative. Bottom left, top right, positive. This thing's got a gradient of -3 on 4. Well, we're told that this is also the tangent of this angle. So we could skip immediately to that and solve for that. But I just want to draw this out a little more carefully, we'll get the scale kind of right for forgive me, this is not going to look like a 3, 4, 5 triangle. This is way out of scale, but that's what we're looking at here. Just forgive the scaling problem. This should be longer, this should be shorter. In fact, why don't I give up and just draw something that looks like it should. There we are. That's a better rendering of it. That happens to be 5 thanks to Pythagoras, and this being a right-angled triangle. Now, if we were just looking for this angle, the angle of this would be 3, the tangent of this would be 3 over 4. Grab my calculator and I'll find you that angle. So now that angle is, I hope you can see it there, 36.87 we'll call that. So that is 36.87 degrees. Now, we need to deal with the fact that this is a negative up here. For those of you who have never done circular trigonometry, the sine or cosine rule, or got beyond basic trigonometry, what you saw here is all you need. The angle that this makes with the x-axis is 36.87 degrees, and we found that by saying that the tan of alpha is equal to 3 over 4 and solving that on a calculator. That's all you need to do. For those of you who understand what's going on here, this negative 3 over 4 is actually this angle in here. But quite sensibly, we measure from here to the nearest x-axis in this direction to get the angle. But just for the sake of completeness, I'll do this, and hopefully it will work for me. My calculator doesn't like this. But what I can promise you is that, oh, actually I think I may be able to do this another way. If this is 36 degrees, then 180 minus 36.87 will be 143.13. Now, as I say, this may be beyond some of you who were looking at this video. So just remember that we've found our answer here. We've got 36.87 degrees. Everything's sorted out. I'm just looking at how I might have found that. Well, the tangent of 143.13 degrees, approximately, 143.13, is extremely close to negative 3 over 4, negative 0.75. That gives us that angle, but this is the answer that we're looking for, 36.87 degrees. I hope that all made sense to you. If you found this useful, please like and subscribe. Thank you very much for watching. I'll see you next time. Bye.